Morning, everyone. My name is Francis Natwell. Here explaining my AI project. The project I'm working on is a rotten fruit detector. It will be able to detect whether in a group of fruits it can divide the rotten fruits from the fresh fruits. That's the project I'm working on. And in my description, usually people face challenges in identifying rotten fruits from the fresh fruits. That's the general view. That's the abstract of my problem. So it would be so hard to separate a large group of fruits, let's say banana, apples, and oranges. Physically, it would be so hard, time consuming, time wasting even. But with this project, it would be so easy to separate the frozen fruits from the fresh fruits. So the data sets I'm using, I got a data set that has fruits. It had three types of fruits. It had oranges, apples, and bananas, whereby it had a group that had the rotten ones and the fresh ones in all the other other aspects. So the factors that I considered in selecting the data set, I had to make sure that data set has all the formats, has more than one format. Yeah, format I could say maybe because you find some data sets. I found some data sets that have only the rotten fruits. But this one, it give me the rotten fruits and the fresh fruits. Yeah. So then the integration to other platforms, then the data set it is, let's say apples, you find there's, there's a class of apples that be be fresh and the color is green or red. But when they go bad, when they rot, that color changes. And this data set that I'm using provides both. It has the green and the red. And then the text and on the cameras that will be used. Because texture is like the feel of the fruit. So when the camera is so good, it has to detect that feel in the fruit texture. Then we have the size, because most fruits have a defined size. Not that they could be too big, but the shape and the size. Then shape is also another feature that it be used in the dataset. Then we have the Bayesian theorem, which is widely used in machine learning as a simple and easy, effective way of predicting classes with precision and accuracy during of the system. Then the Bayesian theorem, where it has terms like the prior probability, posterior probability, and the likelihood plus the evidence. Yeah. Naive Bayes, we have the Bayesian networks, which are also into two. We have the probabilistic and the graphical, but which are here. Then the differences between the Bayesian theorem and the naive Bayes. Naive Bayes is more of a conditional thing. It assumes conditional independence, whereas Bayesian does not. And the algorithm in naive Bayes is easier and faster compared to the Bayesian theorem, which is not as fast as the naive Bayes. Then the difference between naive Bayes and the Bayesian networks. Naive Bayes requires less data. It is more of a particular thing. It requires less data compared to the Bayesian network that requires a wide range of data. Then the naive Bayes describes a particular class, whereas the Bayesian network is more of a general thing. It covers a wide view of the problem. Here are the references to the work. We have the dataset link where you'll find the data sets that I'll be using in the project, and the other links for the Bayesian networks, the Bayesian theorem, and then the features that I used in the project. Thank you all for watching.